This is an exponential growth and decay problem that deals with biology, specifically the percent of air left in the lungs after exhaling. During normal breathing, about 12% of the air in the lungs is replaced after one breath. When we exhale, the majority of the air that is being exhaled is nitrogen, although it also contains oxygen and carbon dioxide. And what we're going to do in this problem is write an exponential decay model, because the amount of the original air in the lungs is going down each time that you take a breath, each time you exhale. We're going to write an exponential decay model for the amount of original air left in the lungs if the initial amount of air in the lungs, the starting value of air in the lungs, is 500 milliliters. And then use that model to determine how much of the original air is present after 240 breaths. By the way, at rest, the average person will exhale approximately 15 to 20 times a minute. So 240 breaths would be in about 15 minutes. So we're figuring out here, if you're starting with 500 milliliters of air in the lungs, how much of that original air will be left 15 minutes later, assuming that you take 240 breaths in that time. Because we're given the rate at which the air is being replaced as a percent, the exponential model that we're going to use is this. A of t equals a sub 0 times the quantity of 1 plus or minus r to the power of t. Let's talk about the parts of this formula. A sub 0 is the initial amount. And in this case, we're starting with 500 milliliters of air in the lungs. A sub 0 is 500. R is the rate of growth or decay. And in this problem, it's the amount of that original air is going down each time we exhale, and the rate that it is going down is 12%. In this formula, we're writing the rate as a decimal. 12% is a decimal, is of course 0.12. And in the formula, t represents time. But this formula is very adaptable. It can be used in a lot of different situations. And in this problem, the time, what we're thinking of as time, is the number of breaths that are taken. And in this case, there are 240 breaths taken. You are exhaling 240 times. Each time, 12% of the air is being replaced. We want to know what percent, what amount of that original air is left in the lungs, what amount of the 500 milliliters of original air is left in your lungs after 240 breaths. Replacing a sub 0 with 500, r with 0.12, and t with 240. This formula becomes 500 times the quantity of 1 minus 0.12 to the power of 240. This is a minus sign because the amount of air, the original air in the lungs, is going down. This is a problem that could be classified as an exponential decay problem. The amount of original air is decreasing by 12% with each breath. At this point, this is a matter of doing the arithmetic. 1 minus 0.12 is 0.88. The exponent of 240, very large exponent, is going to mean that this value will be very small, because we're raising a decimal, a number less than 1, to a large power. So we're going to get a number very close to 0. 500 times 0.88 to the 240th power is 0.10 zeros, followed by a 2, 3, 7 milliliters, and this is approximate. I've rounded this off actually to 13 decimal places. So there's not very much of the original air left in the lungs at all after 240 breaths, which again, if the person is at rest, would be after about 15 minutes. This is a value that's useful to put in scientific notation. In scientific notation, this is equal to 2.37 times 10 to the negative 11th. If the initial amount of air in the lungs is 500 milliliters, 12% is replaced with each breath. After 240 breaths, there will only be 2.37 times 10 to the negative 11th milliliters of original air left in the lungs.